understand about how the applications can be done. What are the different types of applications that are possible for an electric field and a magnetic field? When we try to apply the concepts of electromagnetism, that is, what is the frequency, what is the velocity, what is the velocity of light in vacuum and velocity of light in any other medium, how exactly that can be applied? So these are questions that have appeared in past year board papers, not really in any competitive examinations to be precise, but there are in some bits and pieces, there are some questions that are asked in some examinations for competitive examinations as well. So please try to listen to that carefully. So now we come to the last part wherein we will be discussing about the past year questions of all electromagnetic waves. So let's start off. So the first question is a very straightforward question. It says, in an electromagnetic wave traveling in air, the amplitudes E0 and B0 of the electric and magnetic fields are related as. So how exactly they are going to be related? So if we just try to do it, so we know that the electric field is actually related as the maximum value of the electric field. We got to know about that from the Faraday's law. So that is effectively given by C times B0, where C is nothing but the velocity of light. So the option A is correct here. Okay. Now this is a slightly tricky question. Tricky in the sense you should know. If you know it, the answer is straightforward. It says if Vx, Vm and Vr are the speeds of X-rays, microwaves and radio waves in air, then what is going to be the relation? Generally students are going to be getting confused that they have different frequencies. X-rays would have a high frequency, microwaves, radio waves have a comparatively lower values of frequency, and therefore their wavelengths will also be varying. But the ratio of the product of the frequency and the wavelength is constant. So if it is constant for the case of electromagnetic waves, so it's all of them would have the same value of velocity. They will all be moving with the same velocity. Okay, fine. Moving on further, when a plane electromagnetic wave travels in vacuum, the average electric energy density, we know that there are two values, one because of electric field, other because of magnetic field, right? So we define it as something like 1 over 2 epsilon naught, then you get E naught square, then you have sine square omega, and you have t minus x by c. So this is an expression that you get. Also you get an expression of half b naught square divided by mu naught and sine square omega t minus x by c. Now once you use the expression E naught equals to B naught, so effectively this results into a simple, very simple looking expression of half. This becomes something like this, omega t minus x by c. Okay, so if you take an average value is going to be equals to, once you remove the sine square, so it's going to come out with half epsilon naught E naught square. So this is the total value of the electric field. But if you individually take it, individual values of electric field and magnetic fields, the individual energy content, in that case the average electric energy density, that is what is asked by, so it's going to be given by 1 by 4 epsilon naught E naught square for the case of electric field energy average value, and similarly B naught square divided by mu naught. So this is for the case of magnetic field, and therefore the answer, sorry, this is 4 here, the answer here is the option A. Okay, so what is the thing that I am utilizing? So the thing that I am utilizing is sine square theta as a factor, that is the average value of sine square theta is equals to half. Okay, going further, so when an electromagnetic wave travels in a dielectric medium, its electric and magnetic energy densities. So as we just saw, the electric field and the magnetic field energy density are going to be equal. They will have equal values or equal magnitude. As a result, both of them will be same. The total is going to be twice of each of them. So the average electric energy density and average magnetic energy density are going to be exactly equal. Okay, fine. Coming to the last part, the amplitude of the electric field of a plane electromagnetic wave in air is given by this. So if I just say, so E naught value is given as 6 into 10 raised to power 5. So what is going to be the value of the magnetic field? We know that the magnetic field value is going to be given by E naught divided by C. So that is going to be 6 into 10 raised to power 5 divided by 3 into 10 raised to power 8. As a result, this comes out to be 2 into 10 raised to power minus 3. Okay, so 2 into 10 raised to power minus 3 it is, yeah. Okay, so 2 into 10 raised to power minus 3 it is, so there seems to be some discrepancy here in the answer. This should have been minus 3. So 2 into 10 raised to power minus 3, that should be the answer. So this is the value of the amplitude of the magnetic field. That is the option D. So this concludes the type of questions that we can get from electromagnetic waves. Hopefully this chapter was beneficial for you. Stay tuned for more chapters. Hopefully you would have enjoyed listening to whatever we have discussed in the module. Now, if you still feel that there are any particular doubts that you have, so please visit our site www.askIITians.com. In this, go to the discussion board. Here, you can find all the topics relevant to your questions. You can post your doubts in these relevant topics. And how exactly you are going to do it? Go to the right hand side corner of your screen. As you can see, you can select the category. The categories are defined here. You can select your category, type down your question. You can use your mathematical symbols as well. Else, if you have the question in the form of an image, you can attach the image, post it. We can assure you that the questions would be moderated and answered between 24 to 48 hours after you post it. So keep posting and happy posting. Thank you. In this part, what we discussed about the problems which are related to the electromagnetic waves. So electromagnetic waves are nothing but all the things that you see around us. So there are applications in terms of what is the relationship between the velocity of light in any medium, similarly velocity of light in vacuum, how the electric field amplitude is related to the magnetic field amplitude, how the velocity is related to the wavelength and the frequency. So for different colors, how exactly for different types of waves, how exactly the velocity is varying. So these are broadly things that we discussed. We also understood in this whole chapter about the Maxwell's relations, which basically bring together all the different relationships that we know between electric field and magnetic field. We also got to know about a very important concept which is known as the displacement current. Displacement current plays a very important role for variable electric field, and as a result, what is the magnetic field that is produced. So hopefully you enjoyed listening to this chapter. Stay tuned for more. Thank you.